everybody. So in this video, we're talking about simplifying radicals with variables. So for square roots, variables must have a power that is even or that is divisible by 2. If that is not the case, I'll show you what to do. Now, simplifying with the number, we're not going to do anything different. We are still looking for the largest perfect square that can go into 128. And now with variables, we are looking for each variable to be even. So to start this, here's what I'm going to do. I'm going to have a square root over here with perfect squares and exponents that are even. And over here, I'll have everything that's left. So here, we'll have one radical. And then here, we'll have another radical. So I want, what's the largest perfect square that can go into 128? And that is going to be 64. Okay? Now, if I say 128 divided by 64, what am I left with? And that answer is 2. Now I'm going to look at my variables. So I need variables that are even. Okay? 5 is not an even number. So what I'm going to do is I'm going to write the largest even number below 5. So that's going to be 4. Really, the easiest way to do it is whatever the odd number is, just subtract 1. So here, I'm going to put 4 p's over here, and that means there's 1 p left. So 4 p's, 1 p, that gives me the 5 p's. So remember, we're paying attention to this rule. The powers must be even. Now I have an even power. And over here, there's everything that's left. So q squared is 2 even. Yes, it is. So I can leave this as q squared R18, okay? R18, let me move, I'll erase and rewrite this. So this is going to be R to the 18, and then over here, I can rewrite 2p. Now, I'm going to go through and take the square root of 64, p to the 4th, q squared, and r to the 18. So the square root of 64 is 8. And to take the square root of a variable, you divide the power by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. R, 18 divided by 2 is 9. And then I write what's left. So here, this will be times the square root of 2p. And since nothing else can be reduced, this is my solution. Now, coming over here to this one, we're going to follow the exact same process. So here I have -5, and I'm going to do the exact same thing here that I did over here. I need 2 radicals. So here I'm going to say this is going to be the square root times this square root. So I'm looking for the largest perfect square that can go into 180. And that's going to be 36. So here I have 36. 180 divided by 36 is going to give me 5. Here, 16 is an even number, so I don't have to do anything with it. 10 is even. I don't have to do anything with that. 7 is odd. So I'm going to subtract 1 and put 6 z's over here and leave the remaining z right here. Now, this cannot be simplified. Everything in this can be simplified. So now I have -5 times 6, that's the square root of 36. 16 divided by 2 is 8. 10 divided by 2 is 5. 6 divided by 2 is 3. And I'll have 5z remaining. So all I have to do now is to multiply -5 and 6. So here my solution is going to be -30 x to the 8, y to the 5th, z to the 3rd times the square root of 5z. And this will be my fully simplified solution. Now, this is how you simplify when you have numbers under the radical and variables, but these are square roots. Let's take a look at what we would have if we had cube roots. So here when you have cube roots, the only difference is the variables must have a power that is divisible by 3. So whatever your index here is, all of your variables, you want them to be divisible by this number. So I'm still going to do the same thing. I'm going to have my 2 separate radicals, and I'm looking for the largest perfect cube to go into 128, and then I'm going to test these numbers to make sure they're divisible by 3. So to start, I have 3 times the cube root, and I want the largest perfect cube that can go into 128. So the largest perfect cube that can go into 128 is going to be 64. And then I will have my cube root over here, and then the 128 divided by 64 is 2. 9 is divisible by 3, and so is 21. So here, we'll just rewrite them under this radical. So I have a to the 9th, b to the power of 21. So when I simplify, I'll bring down the 3 again, times the cube root of 64 is 4. And now I'm taking the cube root of a to the 9th. Well, all you do is you take the power and you divide it by the index. So 9 divided by 3 is 3. So this is a to the 3rd power. 21 divided by 3 is 7. And this is going to be multiplied by the cube root of 2. So my simplified answer is going to be 3 times 4, which is 12. A to the 3rd, b to the 7th times the cube root of 2. And this will be my fully simplified solution. Here with the 1 in the middle, we're going to do the same thing. So I'm looking for the largest perfect cube that can go into 192. And that also is going to be 64. So here I have the cube root of 64, and here I have the cube root. This is going to be 3. Here, r to the 8th power. 8 is not divisible by 3. So here, think about this as old school division. What is 8 divided by 3? Well, 3 can go into 8 2 times, so that's 6, and then I have 2 remaining. So what I'm going to do is I'm going to put an r to the 6th power, because 6 is divisible by 3, and then how many r's are remaining? Well, there are 2. So here I'm going to say r squared. Then for s, can 2 be divisible by 3? Well, no, and then you can't make it a smaller number to be divisible by 3. So the s squared is going to go underneath this radical, and the 18 will stay here. So we're going to have t to the 18, and my s squared will be underneath this radical. So here everything can be simplified by a cube root. Here everything is going to stay. So the cube root of 64 is 4. So I have 4 r. 6 divided by 3 is 2. 18 divided by 3 is 6. And this will be times 3r squared s squared. Nothing else underneath this radical can be simplified by a cube root. So here I need to remember my cube root here as well. So this is going to be my solution. Lastly, you can't forget that you can do the cube root of negative numbers. So I'm looking for the largest perfect cube that can go into 32, and that's going to be 8. So this is going to be the cube root of negative 8, and we want this to be negative because we can take the cube root of a negative number. So here we have the cube root of 4, because 8 and 4 would give me 32. Can 17 be divided by 3? No. So how many times can 3 go into 17? Well, it can go in 5 times. And how many left over? 2, okay? So here we know this is going to be to the 15th with 2 left over. Q to the 8th we know that the smallest multiple of 3 that can go, or the largest multiple of 3 that can go into 8 is 6, and there will be 2 left over. So here we can take the cube root of everything that's here. None of this can simplify, so that will stay the same. So it looks like we're going to have negative 2 p. 15 divided by 3 is 5. 6 divided by 3 is 2. This will be times the cube root of 4 p squared q squared. And that will be my solution. All right, that's going to be all for this video. I hope that you found it helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video.